Hello students, in the last class we have seen the atomic radii, the different type of radii, that is the covalent radii, the metallic radii and the van der Waals radius. Okay, and one thing to remember is that the van der Waals radius is greater than that of the covalent radius. Okay, because covalent radius, it is formed by the overlapping of atomic orbitals, their size decreases. Okay, now let's see, today we'll start with the topic, that is the variation of atomic radii along the period. Okay, now let me write one period, second group element, second period element I'm going to write, that is lithium, then comes the beryllium, then boron, then comes carbon, then nitrogen, oxygen and fluorine, and last is the neon. Now we'll see what happens when we'll move from, whenever we are using the word period, because period means horizontal rows, here we are going to use the word left to right. When we are moving from left to right, what happens? Okay, when we are moving from in a period from left to right, generally what happens? The size decreases. Okay, the size, that means the size, this has the greater size, this one is the smaller size. The reason why there is a decrease in size, the reason is that we know that the electron here, the number of proton, that means the atomic number, its atomic number is 3, its atomic number 4, then 5, then 6, 7, 8, 9, 10. Proton number means this is the proton number, that means this is the nuclear charge. Okay, and here when we will see the nuclear charge is increasing by 1 unit. But one more thing happens, the number of electron is being added in the same shell. For example, if you take the case of lithium, if this is the nucleus, in the lithium we know that second period means the electron is present in the second energy level. Okay, this is the second energy level. Now you will find in case of lithium only one electron is there, whereas in beryllium you will find the 4 number of electrons, in boron 5, then carbon 6. You will find the electron is being added in the same energy, in the second energy level. Okay, so here since the electron is being added in the same energy level and the proton, the nuclear charge is increasing, here the electron experiencing more pull, attractive pull. Okay, that means the nucleus is going to attract the electron towards itself. If the number of electron is being increased as well as nuclear charge is increasing, but here one thing that is that the electron is added in the same energy level. That means the distance remains the same between the nucleus and the electron. In that case, when the electron increases in the same energy level, what happens? The size decreases because the pull increases. Okay, so when we'll move from here to here, what happens? The size decreases. Size of the atom decreases. And now we'll see what happens along the group. Along the group, if you'll see, okay, now I'm writing for the group. Group, that is lithium, sodium, potassium, rubidium, cesium, and francium, that is radioactive element, leave that. Okay, now we'll see here the electronic configuration. If you'll see here, the electronic configuration is 1s2, this belongs to the second period, so 2s1, and here it is 3s1, third period, then fourth, 4s1, 5s1. So what we are observing here we are observing that the electron is being added in the new energy level. The nuclear charge is increasing, that means the proton number is increasing, but here what is happening? The electron is being added in the new energy level, and this effect is more pronounced than that of the nuclear charge effect. Okay, and because of that reason, they are experiencing the less pull. The nuclear charge pull that decreases. Why? Because the distance, what happens here, the distance, if the in lithium only second energy level is there, in sodium the electron is present in the third, then goes on potassium fourth. Here we will find the distance goes on increasing. Here the distance is less, then it increases, then increases, then increases. Then here if the distance is increases, that means between the nucleus and the outermost electron, what happens? The pull decreases. Okay, the pull decreases means the size will, if anything is pulling towards us, means the size will decrease. Here the pull decreases means the size will increase. So when we will move from top to bottom, when we are using the word group, we should use the word, yes, top to bottom. Okay, and along a group, जब group का बात करते हैं तो we will use the word from top to bottom, और periods की बात करते हैं तो from left to right. Okay, top to bottom क्या हो रहा है? The electron जो है ऐड होता है इन द न्यू एनर्जी शेल, न्यू एनर्जी शेल में ऐड हुआ तो डिस्टेंस बढ़ रहा है, सो पुल क्या हो रहा है, डिक्रीज हो रहा है, सो साइज इंक्रीजेस. Okay, this is about the variation of atomic radii along a group. Okay, now we'll see the new term, that is the ionic radii. Ionic radii. This is the new term. Okay, what do you mean by ionic radii? It is the effective distance from the nucleus of the ion to the point up to which it has influence. Okay, that is called the ionic radii. For example, we'll see how to find out what is the cationic radius. If we are thinking that this one is, we're taking this one as the cation and this one as the anion. Okay, this one is the anion. So what is the cationic radius? This is the nucleus of the cation, and from here this distance, that will give you the radius of cation, and this distance will give you the radius of anion. Okay, and this study of ionic radii leads to two important facts. What are the two important factors? Let us see the two important factors that led us. That is, the first one is the size of cation. The size of cation is smaller than the parent atom. Smaller than parent atom, and reverse is that of for the anion. The size of anion is greater than the parent atom. Is greater than the parent atom. So we'll see why it is so. We know that the cation, how it is formed. For example, we'll take the case of sodium. Sodium changes to sodium ion. Okay, this is the cation. कैसे हुआ? By losing one electron. Okay, 2, 8, 1, it loses one electron. Here it changes into this. That means cation is formed by the loss of electron. Here what we are finding? The number of electron is being decreased. यहाँ पे proton number कितना था? Proton जो है 11 था, but electron also 11. But in this case, the proton is 11. That means the proton atomic number is not going to change, but the electron decreases. So what happens? At first, the 11 proton was holding the electrons. That means nuclear pull was more. But in this case, the 11 proton is going to hold 10 electrons. That means it is much more than this. ओके, जहाँ पे पुल ज्यादा होगा वहां पे क्या होगा, साइज, अभी कोई न्यूक्लियस की तरफ खींच रहा है तो साइज क्या होगा, छोटा होगा. सो हियर द साइज ऑफ cation इज स्मॉलर बाय बिकॉज द न्यूक्लियर चार्ज पुल, दैट इज द इफेक्टिव चार्ज पर इलेक्ट्रॉन. ओके, इट गेट इंक्रीजेस. द वर्ड यूज करना है इफेक्टिव न्यूक्लियर चार्ज पर इलेक्ट्रॉन, इट गेट इंक्रीजेस. That means the 11 nuclear charge has to hold only 10 electron. So the hold will be more. Okay, so when the hold is more means they will be pulled more. When it is pulling is more means the size will be decreased. Okay, so the size of cation is smaller than that of the anion, the parent atom. Okay, than that of the parent atom. Now we'll see the next fact, that is the size of anion is greater than that of the parent atom. So why it is so? So we'll take the example of chlorine. Okay, that is C, chloride. Chlorine, it is going to gain electron. Okay, it is a gaseous atom and it is going to gain the electron. Okay, here we'll see the number of proton is 17, number of electron also 17. And here the proton number, that means the nuclear charge. Okay, the nuclear charge that remains the same 17, and electron it get increased क्योंकि minus है, that means one electron gain किया तो electron क्या हुआ 8. Here 17 proton is going to hold the 17 electron. Okay, but here the number of proton get decreased. That means the nuclear charge get decreased as compared to the number of electron. अभी यहाँ में क्या होगा, न्यूक्लियर इफेक्टिव न्यूक्लियर चार्ज पर इलेक्ट्रॉन क्या हुआ, डिक्रीज हुआ. दैट मीन्स एक प्रोटोन के लिए यहाँ पे एक प्रोटोन एक इलेक्ट्रॉन को होल्ड करके रखा था, बट हियर one extra electron is there. So the pull will be, the holding capacity is decreased. When holding capacity decreases means the size will increase. So the size of anion is greater than that of the parent atom. Okay. New term, isoelectronic ions. Okay. What is this? Let me write one example. Mg2 plus, then comes the sodium Na plus, then comes F5 fluoride ion, oxide ion, then nitride. Okay, this is the example. एक example है. अब यहाँ पे देखेंगे प्रोटॉन कितना है. What is the number of proton for magnesium? That means the atomic number. Nuclear charge, that it is 12 here, it is 11 here. For fluorine, it is 9. It is 8 for oxygen, and for nitrogen it is 7. The number of electron here, yes, 10, because 12 minus 2, 10. Here 11 minus 1, yes, 10. Then plus 9 plus 1, 10. 2, 10, that means 8 plus 2, 10, and here 7 plus here. That means what is it? Isoelectronic species or ion? That means those ions which have the same number of electrons but different magnitude of nuclear charge. That is called the isoelectronic ions. Okay, same electron number, different nuclear charge. Okay. Now we'll see the trend. What happens to the size? Okay, here what we are observing, here the nuclear charge for this one is the, for magnesium से सबसे ज़्यादा है, इसके लिए सबसे कम है. Electron remains the same. तो अभी यहाँ पे इलेक्ट्रॉन किसके पास ज़्यादा है? इसके पास ज़्यादा है. Remember, nuclear charge more means holding capacity will be more. That means pull will be more. So अगर ये अच्छी तरह से 12 magnesium, that means the 12 proton is going to hold 10 electron. That means the effective nuclear charge per electron, what happens? It get increased. Its effect going to increase. But here it is going to decrease because the 7 proton is going to hold, the nuclear charge is 7, it is going to hold 10 electrons. So it will be harder. So here you will find the size iska sabse zyada hai, size iska kam hai, and it decreases in increases in the order like this. Okay, जहाँ पे इलेक्ट्रॉन का नंबर बढ़ता जाएगा, प्रोटॉन का नंबर कम होता जाएगा, साइज क्या होगा? इंक्रीज होगा. दैट में याद रखना है, where the nuclear charge is more, in case of ions, there the pull will be more, and pull will be more means size will be less. Okay, this is about the isoelectronic ions. Okay, now we'll see the next property, that is the ionization enthalpy. Okay, what do you mean by ionization enthalpy? So here what is it is given? Ionization enthalpy, denoted by, we are going to denote it by, because the energy change is going to happen, I represents the ionization enthalpy. Okay, what is this? It is the energy required to remove the electron from an isolated gaseous atom in its ground state. So we will take the example. For example, this is the general example. Okay, and whenever we are removing it, we should remove it from the isolated gaseous atom. The solid state, the electron cannot be removed. Okay, the ionization energy which is required to remove the electron, okay, that is called the ionization enthalpy. That means whenever we want to remove the electron, if you want to remove this electron, okay, and that energy हटाने के लिए, electron को हटाने के लिए how much energy is required? That energy is called the ionization enthalpy. Its unit is kilojoule per mole. Okay, unit of ionization potential is given in electron volt per atom, and which is equals to ionization enthalpy by the quantity 96.49 kilojoule per mole. That means 1 electron volt per atom is equals to 96.49 kilojoule per mole. Okay, this is the ionization enthalpy. That means what is ionization enthalpy? The energy required to remove the electron from the isolated gaseous atom. Okay, now we'll see one more term is there, successive ionization enthalpy. What do you mean by this? Successive. Here one word we have used, successive. Okay, successive ionization enthalpy. What is that? Actually, when an atom here, only one of the gaseous atom loses one electron. If an atom is going to lose more than one electron, remember, it does not take place, for example, aluminium जो है, we know that हमने पढ़ा था, aluminium is going to lose 3 electron, and by losing 3 electron, it will attain the noble gas configuration. Okay, 2a 3 था, 3 electron lose करके noble gas can. But this does not happen in one single step. Not simultaneously, it takes place in step by step. Okay, that is why the ionization enthalpy is called the successive ionization enthalpy. Okay, now we'll see the example. For example, इसके लिए देखते हैं aluminium जो है, it is going to lose 1 electron. First of all, it will lose 1 electron. Okay, और यहाँ पे जो energy लगता है, that is called the first ionization enthalpy. 1 लगाते हैं. This is the first ionization enthalpy, which is equals to 577 kilojoule per mole. Okay, now it is again the aluminium plus ion is going to lose this another electron, that is 2 plus, and here the ionization enthalpy, that is called the second ionization enthalpy, that is IH2, which is equals to 1816 kilojoule per mole. And the third Al2 plus is going to lose 1 electron. Okay, and here the ionization enthalpy is called the third ionization enthalpy, and which is equals to 2744 kilojoule per mole. So it takes place, this energy enthalpy 1, 2 and 3 is called the successive ionization enthalpy. Step by step it is taking successively, it is taking place. Okay, and here what you are finding, that here the ionization enthalpy increase, that means the energy get increases. Why it is? तो reason क्या है, यहाँ पे देखिए, here the number of proton and the number of electron for this case remains the same. So pull is there, but not much higher. So this much energy if you are providing means we can remove the electron. But here what happens, one electron get decreased. जब भी electron decrease होगा, nuclear charge pull क्या हो जाएगा, increase हो गया. तो nuclear charge pull increases means we have to supply with more energy is required to remove that electron. That is why the energy it increases. And in the third case again 2 electron is less than the proton nuclear charge. So here much more energy is required. This is the reason why the ionization enthalpy for the third it is highest. Okay, understood? Okay, we'll see the next, that is what are the factors that affects the ionization enthalpy. First one, atom. So remember, when the size decreases, why the size decreases? Because the pull is increased. If pull is increasing means, if somebody is holding the electron tightly means more energy is required. That means when the size decreases, when the size is decreasing, ionization enthalpy is increased. Remember, that means more energy is required to remove electron. Okay, and reverse is for if the size increases. Why? If size is increasing means, size of the ion is increasing means, why it is increasing? Because the distance is increasing between the nucleus and the outermost electron, as well as why if it is increases means the attractive pull for the nucleus and the electron also decreases. That means pull जो है कम हो रहा है. If anyone is holding anything loosely means we can easily take it out. ठीक है, आराम से हटा सकते. तो here जब size increase हो रहा है तो distance बढ़ा, distance बढ़ने से क्या हो रहा है, nucleus का जो pull है for the electron वो भी कम हो गया. That means here less energy is required. That means the ionization enthalpy in this case is very less. Remember, size decrease हो रहा है तो ionization enthalpy increase होगा. That means और यहाँ पे size increase हुआ है, that means ionization enthalpy will decrease. Okay, now we'll see the next factor, that is the second factor, that is the magnitude of nuclear charge. Okay, magnitude of what happens when the nuclear charge increases or decreases. Nuclear charge. Okay, when the nuclear charge increases, that means the proton is being increased. If the proton number is increased, one more thing you should know, that then if the electron is being added in the same energy level, If this one is increasing, if the proton is being increased, that means the nuclear charge is increasing. If the proton is added in the same energy level, the pull also increases. If the electron is added in the different energy level, then the pull will decrease because the distance is being increased. Okay, the holding capacity will decrease. So remember, when the nuclear charge increases and the electron is being added in the same principal energy level, what will happen? The pull will increase. The pull will increase means the ionization enthalpy will also increase. That means more energy is required to remove the electron. Okay, now this is the second factor. Okay, now see the third, that is the screening effect. Third is the screening. The third factor, screening. Screening effect or shielding effect. Okay, what do you mean by that? In the case of, remember, in the case of multi-electron species means where the number of shell, energy shell increases. So there the electron present in the outermost energy level do not experience the complete nuclear charge pull. Why they are not experiencing the complete nuclear charge pull? The reason is that because of the repulsive interaction of the inner electron. Here in the inner shell energy level, the electron is present, and that is going to produce the repulsion force. Okay, repulsive force it is going to produce. So what happens? The pull for this one decreases. That means inner shell is going to shield the outermost electron from the nucleus. एक shield, एक पर्दा का काम करेगा. तो एक attraction होना चाहिए, but ये क्या कर रहा है? The inner shell आके क्या कर रहा है? Screen कर रहा है. तो इससे क्या होगा? The inner shell increase, अगर inner shell जितना increase हो रहा है, energy shell कितना increase हो रहा है, that means shielding effect उतना ज़्यादा हो रहा है. जितना ज़्यादा होगा, that means pull will decrease. Okay, and pull decreases means the electron can easily be removed. Electron can easily be removed means the ionization enthalpy decreases. Okay, that means screening effect increases, then ionization enthalpy decreases. That means less energy is required to remove the electron. Now next one, the next factor is the penetration power. The penetration effect of the electrons. Okay, penetration effect of electrons. So we know that, remember, whenever in the same energy level, if s orbital, s, p, d and f subshells are present, orbitals, electrons are present in the given subshell. If it is present in the s subshell, that means s subshell is more near to the nucleus as compared to p, then compared to d and compared to f. Now, which one will experience the more attractive pull? The s, the electron present in the s subshell will experience the more attractive pull. So here the penetrating power for s will be the greater than p, then d, then f. Okay, that means here more energy, ionization enthalpy required to remove the electron present in the s subshell will be more, and here the electron present in the f orbital means the electron can easily be removed. Why? Because the penetration power for f is less. Here the penetration power for s is more, so more energy is required. Okay, and the last factor, that is the electronic configuration. Electronic configuration. Okay, now the electronic configuration, remember, if the electron present in the outermost shell is completely filled or completely half filled, that means it is in a stable state, then more energy is required as compared to other condition. Okay, that means half filled and fully filled orbitals need more energy to remove. That means the ionization enthalpy is increased in that case. Okay, now let's see, this is about the factor, the 5 factor, that is the size of atom, size of the atom. If it is decreased, ionization enthalpy is going to increase. Okay, size decreases, ionization enthalpy increases. In the same way, if the nuclear charge is being increased, ionization enthalpy also increases. Screening effect increases, ionization enthalpy decreases. Okay, and penetrating power increases, ionization enthalpy increases. And the electronic configuration, half filled or completely filled state, that is stable state. So in that case, more energy is required to remove electron. Okay, this is the 5 factor. Now we'll see the variation along a period and variation along a group. Okay, now we'll see the variation of ionization enthalpy along a period. Period में क्या हो रहा है? We'll take the example of second period. Lithium, yes. Then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine, then neon. Okay. And here we'll see I have said that as the size decreases, ionization enthalpy, what happens? It increases. That means more energy. But here some different exception is there. Remember, the ionization enthalpy is in this way. We have to write it increases in this order. That is, then beryllium, then comes carbon, then comes oxygen, then carbon, then comes oxygen, then comes nitrogen, then fluorine, then neon. Why this changes happen between these two? Now let's see the electronic configuration of all the 1s2, 2s1. Here it is 1s2, 2s2. In this case, 2s2, 1s2 is there. Leave the 2s2, then 2p1. यहाँ पे 2s2, 2p2 हो जाएगा. यहाँ पे 2p3 होगा. यहाँ पे 2p4 होगा. यहाँ पे 2p5 and here 2p6 completely filled. आगे वाला same होगा. Same as this one. Okay. So यहाँ पे what you are observing, the outermost को देखना है आपको. यहाँ पे देखना है आपको. Here observe this one. Okay. Here why the ionization enthalpy of beryllium is more than that of boron? The reason is that here it is completed. The S subshell can accommodate 2 electrons. So here maximum 2 electron is there. To remove electron means more energy is required. So its ionization enthalpy is more than that of boron. And in this case, in case of nitrogen and oxygen, it should be size of oxygen is smaller than that of nitrogen. But here you will find the P3 condition. P3 condition means completely half-filled condition, and completely half-filled condition means more energy is required to remove electron. So its energy increases. So to remove the electron from nitrogen, more energy is required compared to oxygen. Okay, then comes this, follow the same trend. This is the way. So in general, we can say the ionization enthalpy increases along a period. But here few exception is there because of the electronic configuration. Okay, now we'll see along a group. Group में क्या होगा? That is lithium, then sodium, potassium, rubidium, cesium and francium. Okay, here the ionization enthalpy, we know that the size is increasing. Size is increasing means the pull decreases. So the ionization enthalpy along a group, when we'll move down a group from top to bottom in a group, top to bottom में जा रहे हैं तो क्या होगा? Ionization enthalpy decreases because less energy is required to remove the electron. Okay, so this is about the ionization enthalpy along a period and along a group. Okay, now we'll see the next, that is the next factor, that is the next property, electron gain enthalpy. Electron gain enthalpy, it is just opposite to that of the ionization enthalpy. Okay, what is electron gain enthalpy? It is energy released. There the energy is released or energy is added to remove the electron. Here just opposite, here energy is released when, or energy change is taking place when an electron is added to the isolated gaseous atom. Okay, here the electron is being added. This is the gaseous atom. Here the electron is being added to the isolated gaseous atom. And here that energy is required. That energy is called electron gain enthalpy. And it is denoted by electron gain enthalpy. It is denoted by delta I लिखते हैं तो ionization enthalpy. Here we will be writing Eg. Okay, Eg represents the electron gain enthalpy. यहाँ पे क्या है? इलेक्ट्रॉन को ऐड करने के लिए जितना एनर्जी, जितना एंथैल्पी चेंज हो रहा है, that is called the electron gain enthalpy. Here comes the new term, that is the successive electron enthalpy. Okay, जैसे हमने देखा ionization enthalpy में भी हमने successive word use किया था. Here also to remove more than one electron, there we have used successive ionization enthalpy. Here to add more than one electron, we use the word successive electron gain enthalpy. Okay, for example, oxygen, if it loses electron, does not the gaining of electron does not take place in one single step. Okay, if the gaseous atom is going to gain the electron, it does not take place in single step. Okay, that means here the second electron is being 2 minus. Okay, then here the energy required, that is the electron gain enthalpy required, that is equals to minus 141 kilojoule. And here the electron gain enthalpy required for this one is plus 780 kilojoule. Here you will see that this one is called the electron gain enthalpy 1. First in electron gain enthalpy, this is the second electron gain enthalpy. And these together is called the successive electron gain enthalpies. And you will find here the electron gain enthalpy, here it is negative, here it is positive value. The reason is that here the electron is added much easily. Remember, if the negative value represents means more easily is the acceptance of electron by the given atoms. Okay, that means greater is the tendency to take the electron, gain the electron. Here the positive values means their tendency is less. Okay, why it is so? क्यों ऐसे हुआ? The reason is that again here what happens, यहाँ पे जो इलेक्ट्रॉन किसे यहाँ पे इलेक्ट्रॉन ऐड करना है, here what happens, here the negative charge जो है प्रोटॉन जो है remains the same, प्रोटॉन चार्ज सेम है. यहाँ पे क्या हो रहा है, प्रोटॉन जो है, अगर प्रोटॉन ऑक्सीजन का जो है 8 है, इलेक्ट्रॉन जो है it is 9 here. That means इलेक्ट्रॉन जो है मोर ज्यादा हो गया, तो अभी इलेक्ट्रॉन किसके पास आ रहा है? That means electron is added to the negatively charged oxygen. तो यहाँ पे ये this extra electron is going to repel the incoming. जो इलेक्ट्रॉन आ रहा है उसके पास, उसको रिपल करेगा. और रिपल्शन हो रहा है तो उसके लिए क्या चाहिए? More energy सप्लाई करना पड़ेगा. That is why in the second you are finding the more energy is to be supplied. Okay, that is the energy change is more. Okay students, now we'll see the assignment. Hope करती हूँ कि आज का क्लास जो है आपको समझ में आया होगा.